We're going to be solving polynomial inequalities first, and we're just going to go through the steps above here. First thing we're going to do is we're going to move everything to one side of the inequality and set it to 0. So we have x squared minus 4x minus 5 is less than or equal to 0. And now you're going to solve the related equation, which means you're just going to temporarily replace your inequality with an equal sign and solve the way you would if it were an equation. So now it just looks like a quadratic equation, and the way we try to solve a quadratic equation that looks like this is to factor it. And this factors nicely into -5 and +1. And if you solve that equation, you're going to set each factor equal to 0. And you get x is equal to 5 and x is equal to -1. Okay, so step 1 is to move everything to one side. Step 2 is to solve the related equation. And now we're going to go ahead and take those solutions and we're going to plot them on a number line. Those solutions are called your critical numbers, and you're just going to put those critical numbers in order. So -1 comes before 5, and that's how I'm going to place them on the number line, just a regular x-axis number line. And then I'm going to take my factored quadratic, and I'm going to write it down. I'm going to keep it factored, but I'm going to put the inequality symbol back in. This is what I'm going to use to test each interval to see whether or not the numbers in each interval are part of the solution to my inequality. I only need to test one number in each region in order to determine whether the whole entire interval is part of my solution set. Also, because of my symbol being less than or equal to, that symbol represents a closed circle, and so the actual critical numbers would be part of the solution. Okay, so let's go ahead and test a number over here to the left of -1. I usually just pick the next number over, but you don't have to. You can pick whatever you want that's easier. Or if you find something's easier. So I'm going to go ahead and substitute in to each factor. -2 minus 5 is -7. And -2 plus 1 is -1. And I'm going to test to see if that result, when I multiply, is less than or equal to 0. I get 7 less than or equal to 0, and that's false. 7 is not less than or equal to 0. So this section right here, this interval, is not part of my solution set. Now there's something that can make the process even quicker, and that's realizing that you don't even need to have the numbers here. I don't even need to know that that came out to be -7 or that came out to be -1. Just knowing that I have a negative number just knowing that I have just knowing that I have a negative number for each of these factors, and knowing that a negative times a negative gives me a positive result is enough to tell me that this is false. A positive number is not less than or equal to 0. So I don't even need to see that little 7 right there. Any positive number is not less than or equal to 0. It's false. So as I plug in or substitute in to test a point in each region, I don't even have to figure out what the number is. I just have to figure out if the factors come out to be positive or negative. So let's try the next region. We are going to try a 0. I'm going to cry if this doesn't stop. No. Okay. Here we go. All right, so then we're going to substitute a 0 in for each factor. I get a negative 5 and a positive 1. And a negative times a positive is a negative number. N is a negative number less than or equal to 0? Absolutely. So this next section is true. And this is part of my solution set. That's some pretty bad shading right there. And then we'll go ahead and try a number over here. So I just picked the next one over. I'll try 6. And 6 minus 5 is positive. 6 plus 1 is positive. A positive number times a positive number would be an overall positive answer. And a positive is not less than or equal to 0, so this is false over here. Now this is pretty much all scratch work. You need to finish off your answer and put it in interval notation. So we're going to have bracket for closed circle, then write down our -1 up to 5, and then bracket for the other closed circle, and that's your solution set. All right, let's go ahead over here and move everything to one side. And I'm going to subtract the x and the 3, minus x and minus 3, and I get x squared plus 2x minus 8 is greater than 0. Okay, so let's go ahead and solve the related equation. We'll solve by factoring. Factors of 8 that add to 2 are 4 and 2, minus and plus. Okay, so we have each factor gets set equal to 0, and x is equal to -4, and x is equal to 2. And we're going to go ahead and plot those critical numbers on a number line. And -4 comes before 2. And then I'm going to write down the factored form of the quadratic and put my inequality symbol back in. Okay, so now we're going to take a test value in each region and substitute it back into our problem. Let's go ahead and start with trying a -5. A -5 substituted into the first factor gives you a negative. A -5 over here substituted into the second factor gives you a negative, and the overall result is positive, and a positive number is greater than 0. And so this guy is true over here, and that'll be shaded. Now my symbol is a greater than symbol and does not have the extra equals underneath that symbol, which means the circles are going to be open. So these guys are going to be open. Okay, so let's try a number in the middle here. I'm going to try 0. And when I substitute a 0 in for x plus 4, I get, oh, here we go again. When I substitute a 0 in for x plus 4, I get a positive number. I do not know how to fix this issue. Okay, and then I'm going to plug a 0 in for x minus 2, and I get a negative number, and a positive times a negative is a negative, and is a negative greater than 0? No, so this is false region in here, and over here at the end I am going to plug in a 3. We're substituting a 3. 3 plus 4 is a positive result. 3 minus 2 is positive, and my overall result is a positive times a positive, which is positive, and is a positive greater than 0. Yes, so that's true. Now, normally I actually write true and false and wait to shade later, but because my program is not cooperating with me, I'm not working through this with a nice rhythm or flow. So I probably would put a true and then a false and then a true if I were working through this more efficiently and then shade in later. But anyway, at the end here, you still have to put your final answer in interval notation. So we're working from negative infinity up until -4, parenthesis for the open circle, unioned with 2 to infinity, and parenthesis around that 2 for the open circle. And don't forget, infinities always get parentheses. And if I work up the energy to redo this video, I will redo it at some point, but probably not today. So there's one more example to come, and hopefully my pen will cooperate with me more.